So that's a really very brief overview of why we actually launched these satellites and the different kinds of applications. If you want to see the website that's based on the book, there it is right there, but you should start just by checking out the exhibit. Thanks very much for your attention. Questions?
I've been to a website called maps.lineup.com.
Okay.
That uses a lot of this kind of imagery, but what I was amazed at was, for example, zoomed in on the Golden Gate Bridge.
Right.
And you've got down pretty good detail. You could click on something called bird's eye view. It would go in even further, and then you could rotate around. How in the world are they getting?
He's asking about, now I'm not familiar with that particular website, but I've seen, there's a Microsoft version that I have seen. He's asking, well, you can zoom into some of these internet sites, and then you can actually click another thing and actually move around it. Again, I'm not sure what that is. If I saw it, I'd probably be able to give you an answer. But I know that on one of them, you zoom in, and then you click, and yeah, I think they call it bird's eye view. Maybe it is the same thing. And what I've seen anyway is based on aerial photography. So you've got the satellite image that looks straight down. Then if you click that other link that says bird's eye view or whatever it is, you're actually looking at oblique aerial photographs. So it's a picture taken from an airplane looking at an angle.
They blended it pretty well. You can tell the transition part of it from
Yeah. Remember when morphing became, they got good at combining, that's probably how they did it. Yeah, but I don't know. I'd be interested in seeing it. I'll check it out. All right. Yeah. Yes, sir.
Could you give me an estimate of how many satellites are actually up there?
How many satellites total are up there?
Including the reconnaissance and the commercial.
Total, how many total satellites are orbiting that are still working? Or total satellites that have ever been launched is many thousands. Total satellites that are working, are on the order of a 4-digit and a low 4-digit number. In terms of remote sensing satellites, now we're talking about dozens. Yeah. And I'm sorry to be a little bit vague, but some of these satellites, have imaging sensors and they do other things. So the categories get a little bit hazy, but
Space junk, and I'm just thinking.
Space junk, yes.
Part of the waste that's up there that you might have to deal with in the future.
Space junk is an issue not just for remote sensing satellites, but for all satellites in general. It depends where you're putting them. There are some orbits that are very popular, like that geostationary orbit, all right? And there are actually rules in place now that say if your satellite is dying, you have to leave a little bit of fuel on board so that you can move it out of the way. But sometimes satellites die too fast. Also, sometimes people do silly things like they blow up their own satellites intentionally, which happened last year with a Chinese satellite to prove they could do it. And that increased the amount of space debris in low Earth orbit by about 30% in one day. The good news about space debris in low Earth orbit, like where the space shuttle orbits, that stuff eventually re-enters the Earth's atmosphere. Because even though you're above most of the atmosphere, there's a tiny bit of drag. So you give it a couple decades and it'll enter the Earth's atmosphere. But up where remote sensing satellites operate, they'll stay up there. The good news is, again, there's lots of space in space. Yeah. We've only had, in fact, I'm only aware of one example where a satellite actually, an operational satellite was actually hit. There was an actual impact and it affected the satellite. It was a French satellite and it had one of these booms that stabilized. It was supposed to help stabilize it, and it turns out something hit it and whacked it, maybe whacked it off, and they were able to get it back. That's the only example that I know of where there was an unintentional impact in space. Yes?
Who's making these rules that you speak
Oh,
about?
good. Who's making the rules? Yeah, good question. I should probably be. The rules are sometimes pretty informal. So there's no. There are no official trees saying, okay, you need to remove this satellite or that, because we have different operators in different countries. So let me rephrase that and say that those are informal rules. Those are understandings. Another example of an understanding is with weather satellites. Because we have, the planet is obviously round, and we have satellites in geostationary orbit all around it. And they've sort of divided up the planet. The U.S. National Oceanographic and Atmospheric Administration operates 2 operational satellites, one over the Atlantic and one over the Pacific to look over North America, right? Then there's a European Weather Satellite Consortium. They operate 2 satellites, one over the Indian Ocean, one over their end of the Atlantic. Then there's a Japanese Weather Satellite Agency that looks over that side of the Pacific. So those 5 satellites give you global coverage. Other countries have other satellites in there too, but those, I'm aware that those actually are coordinated to try to give global coverage. Yeah. Yes?
Apart from the weather and the military applications, have you done any cost-benefit analysis on all this data gathering?
Yeah, she's asking, is it worth all the money that's going into this? I have not done the cost-benefit analysis myself, no. The weather satellites, the one thing that makes that, the most useful part of that is probably the tracking of the storm systems. Yeah, so you can warn people to get out of the way. Yeah, and it saves lives. No, I don't think that would be a hard thing to do a cost-benefit analysis on. When it comes to environmental remote sensing, we're still learning how to use these tools. Okay, these are things we're still trying to understand. How is the planet changing through time? Right? How is the atmosphere changing through time, and what different ingredients play into that? Whether it's the interaction between the ocean and the land surface. So it may be down the road that it'll tell us how the atmosphere is changing through time, and it'll help to ameliorate some of that, or maybe not. It's an impossible thing to really know. Yeah. Yes?
What new satellites do you expect to be launched that are exciting?
What new exciting satellites do I expect to be launched? Good question. Well, I mentioned one thing, that there's going to be there is this new generation of commercial satellites that give you the images where you can peer into your neighbor's backyard, you know, that kind of stuff, for better or worse. There are going to be new versions of those that are even higher, more detailed. That's going to be an interesting thing to view. We also have a lot of, on the environmental side, a lot of interesting things going on where we have new sensors that can do a better job at things like tracking rainfall. You might wonder, you might think it's an easy question to answer. How much does it rain in Tennessee every year? Actually, we can't really answer that question in terms of like the volume of water that actually falls out of the sky. There's a lot, so new satellites are going to be able to measure that directly, which will tell us a lot about again, how much it rains, and that tells us about the movement of energy. There's a new satellite that's going to track carbon dioxide directly. You're all aware of climate change and the impact of greenhouse gases, and we're trying to better get a handle at what's going on and what's not going on. And carbon dioxide is one of those gases that we know is key in that, but there's still a lot of unknowns about how much carbon dioxide goes up, how much goes down, and where it's stored. So there's a new satellite that will actually directly detect that gas, which is going to tell us a lot. It's going to answer a lot of those questions. Yes, sir? What kind of spatial resolution would you see in the military satellites? Well, I'm not on the military side, but I do know the laws of physics, and I know how big their mirrors are. And so I don't know. I can't give you a specific numerical answer, but I can answer it this way. And I often like to phrase it this way. When you see in the movies, the Hollywood movies, one thing to keep in mind is you can't, it's not a video camera. You can't chase people down the street. Okay, you can take snapshots. You can't sit there at a computer terminal and tell the satellite to move over there. Changing a satellite's orbit takes a long time. Okay, if somebody's sitting there reading a newspaper, you won't be able to read the newspaper over his shoulder. You can definitely tell what kind of car he's driving. You might be able to read his license plate. On a good day. The conditions, as I said, we know how big these satellites are because, well, we know what the rockets are, and we know the size of the mirrors. They're very similar to the Hubble Space Telescope, except they don't look up, they look down. So that just gives you a flavor for it. But the real answer to your question is, I don't know. Yes?